It is given a matrix M. Question A. Find the eigenvalues of a given matrix. To find the eigenvalues, we should consider a given matrix with additional minus lambda along the main diagonal, and its determinant should be equal to 0. So we should consider determinant of -4 minus lambda to -3 3 minus lambda should be equal to 0. Determinant of 2 by 2 matrix formula is given in a data booklet. It's just this product minus this product. So it becomes -4 minus lambda multiplied by 3 minus lambda minus -6 or just plus 6 is 0. And we need just expand it. I want to factor out minus here and minus here, it to be more simple. It's not necessary. It's the same as 4 plus lambda, lambda minus 3 plus 6 is 0. Then for lambda plus lambda squared minus 12 minus 3 lambda plus 6 is 0. It becomes lambda squared plus lambda minus 6 is 0. And we get the usual quadratic equation with respect to lambda. You may use just a calculator, or discriminant can be used. I want to use the sum and product rule. And sum of roots is equal to minus b over a, and product is equal to c over a. A is 1, b is plus 1 also, and c is -6. So sum is -1, product is -6. Product to be -6, it may be what, 2 and -3, -2 is 3, and you can see sum to be -1, it's 2 and -3. So roots are 2 and -3. So the required eigenvalues are 2 and -3. M can be written in the form M is matrix P multiplied by matrix D and multiplied by the inverse of P, where D is a diagonal matrix. Question B, I write down D and find P. This formula is given in a data booklet, and this matrix D, it's a matrix constructed on the eigenvalues, and it looks like, and eigenvalues are on the main diagonal, so it becomes 2 and -3 on all other values are 0. So it looks like this. It may be -3, 2, 0, it doesn't matter. But what is matrix P? Matrix P is a matrix constructed on the eigenvectors, and it's an eigenvector corresponding to this eigenvalue, and here must be eigenvector corresponding to this eigenvalue. So we should find eigenvectors corresponding to the found eigenvalues. And how to do that? The first eigenvalue is 2, and in general, if we want to find eigenvalues, eigenvectors, we solve the next problem. Matrix multiplied by some vector is equal to lambda multiplied by the same vector, and this vector is the required eigenvector, and lambda is the required eigenvalue. So we just consider this our matrix. It's -4, -3, 2, 3 multiplied by some vector, let it be xy, is equal to lambda. We consider lambda to be 2, and the same vector, and we need just multiply these two matrices. How to do that? We just rewrite this xy as a row, and then it becomes -4x plus 2y and -3 plus 3y. We get 2 by 1 matrix, and is equal to 2xy, and then just equate rows. It becomes -4x plus 2y is 2x, and -3x plus 3y is 2y. And from the first it becomes 2y is 6x, y is 3x. And if we consider eigen vectors, their magnitudes don't matter. We need just direction, or direction is important only, and that's why we can choose absolutely any values for x, for y, just these must be true. And usually we take the least the least integers for x and y, and we can choose, for example, x to be 1 and y becomes 3, and it's the required eigenvector corresponding to lambda, which is 2. So p1 is 1, 3. And do the same for the second lambda, which is negative 3. mu is lambda u. Our matrix negative 4, negative 3, 2, 3 multiplied by x, y is lambda, which is negative 3 x, y. Then again multiply, it becomes negative 4x plus 2y. Negative 3x plus 3y is negative 3x, y. It becomes negative 4x plus 2y is negative 3x. Negative 3x plus 3y is negative 3y. If you can, you may write this directly when you multiply matrices, just equating rows. And from the first we get 2y is x, and it's not necessary to consider the second, because the second equation is dependent, and you will get absolutely the same result. So we can choose, for example, y to be 1, x becomes 2. So 2, 1 is the second vector. Hence, our matrix P becomes, notice that if the first it's 2, so it must be the first must be a vector corresponding to a lambda, which is 2. So it's 1, 3, and the second is 2, 1. And it's the required matrix P. In general, to get this representation, it can be easily found. The inverse of P formula is given in a data booklet, and in general, why do we need this representation? Because if we raise matrix M to some power n, it can be easily done. The formula is also given in a data booklet. And that's all for this question.